Okay, Assalamualaikum semua and salam sejahtera. Okay, so today we will continue with subtopic of structures, which is frame and machines. Okay, so this is the subtopic. Okay, frames and machines under structures. Okay, so under structures, frames and machines. Okay, so okay, a structure is called a frame or machine, okay, if at least one of its individual members is a multi-force member, okay. Multi-force member is defined as one with three or more forces acting on the structure, okay. So we see frames first. Okay, frames are structures which are designed to support applied loads and are usually fixed in position. Okay. Meanwhile, machines are structures contain moving parts. Okay. Okay. And then the forces in these members in general will not be in the directions of the members. Okay. And then next. Okay, so in this part, in this chapter 3, okay, in this chapter, we focus on the equilibrium of interconnected rigid bodies, okay, which include multi-force members. Okay, so first we have to isolate the member with a free body diagram, okay, and then apply the equations of equilibrium. Okay, and then not to forget, we have to apply the principle of action and reaction. Okay, this apply to support such as ball and socket joint. Okay. Okay, then so we just begin by establishing all the forces external to the structure. Okay, treated as a single rigid body. Okay, first what we have to do is we have to compute the external forces. Okay, so we have treat the whole body as a single structure. Okay, and then we dismember the structure and consider the equilibrium of each part separately. Okay, and then we just do part by part. Okay. Okay, now okay, in any event, it is absolutely necessary that a force be consistently represented on the diagram, okay, for interacting bodies, okay. And then, okay, the force components must be consistently represented in opposite directions, okay, on the separate free body diagrams, okay. Okay, this one, what does it mean by this one? Okay, first, this one, okay, this one, okay. Let's say we have for this, okay, for this member, this is the forces that involve. Okay, we will have a X and a Y. Okay, and then this is the first member. Okay, first member, and then we have second member. Okay, for the second member, we have to apply in opposite direction. Okay, so we see that AX to the right, so this one to the left. Okay, And for AY, for first member, it is upward. Okay, so in second member, it will be downward. Okay, it must be opposite to each other. Okay, then, okay, for a ball and socket connection, okay, then we have to apply the action and reaction principle. Okay, so when it involves ball and socket connection, we will have like three different forces direction. Okay, so then, okay, so lastly, okay, we can avoid simultaneous solutions by careful choice of the member or group of members for the free body diagram. Okay, and by careful choice of moment axis. Okay, so now we go for example. So okay, so we look at sample problem 4.7. Okay, so the question: neglect the weight of the frame and compute the forces acting on all of its members. Okay, so what we have to do here is, okay, we have to compute the forces of all the members. Okay, okay, so this is the structure here. Okay, first we have to notice that, okay, is it stable or not? Okay, is it rigid or not? Okay, so in this case, the frame is not rigid unit when removed from its support. Okay, let's say kita dah remove this one. Okay, remove this one, it is not rigid. Okay, why? Okay, since BDF is a movable quadrilateral. Okay, not a rigid triangle. Okay, so here, okay, dia dekat sini macam can be moved. Okay, unless the triangle. Kalau triangle it is rigid. Okay, so therefore macam it is hard lah to compute the external reactions. Okay, okay, but we can determine the reactions, the vertical reactions at A and C. Okay, so this is the structure. Okay, so what we have to do is, okay, first, when we identify there is support, we have to what? We have to identify. Okay, so let's say for the support, it has two forces. Okay, Y and X. Okay, let's say no, this is different. Okay, let's say is in this way and in this way. Okay, so this one must be opposite. Okay, this one will be to the left. Okay, and then this one will be upward. Okay, so remember opposite direction. Okay, okay, and then okay, so we take moment at C first. Okay, since most of forces in direction of C. Okay, so for equilibrium, summation of moment at C must be equal to 0. Okay, so now we will take at C. C, right? Okay, so we have to identify, sorry, okay, the forces that is involved. Okay. Okay, so we have this one, the 50 lb. Okay, so the distance will be like this. Okay, from the force towards C. Okay, moment equal to Fd. Okay, this one for 90 degree. Okay, so it is moving in which hand? Okay, it is left hand, so it will be negative. This one, okay, it will be moving 90 degrees downward. Okay, and then this one is 12. This one is 40, the distance. So this one also left hand, so it is negative. Okay. Okay, and then we have AY. Okay, AY. I forgot. So we have to name this one as this one is AX, this one is AY, CX, CY. Okay. So the distance is from here, from the force towards C. So it is 30. So this one is right hand side. So it is positive. Okay. So we have negative 50, 12. Okay. Negative 30, 40 plus AY 30 equal to 0. So AY we get equal to 60. Sorry, 60. Okay, 60. And then we compute the summation of force. Okay, compute summation of force vertical. Okay, equal to 0. Okay, so we have here is, okay, so we just do the label the forces again. Okay, so we have, okay, so AY we have 60. And then for CY we don't know yet. Okay. Okay, and this one we have to compute in this way. Okay, so we have to know the distance first. Okay, from here, okay, this is the bigger triangle. Okay, so this is 40, right? And this is 30. Okay, 30. So this one we have 50. Okay, so we can say that it is ratio 4, 3, and 5. Okay, same to this also. It is 4, okay, 3, and 5. Okay, let's say we take this one as theta. Okay, so here I just simplify. Okay, explain. So cos theta is equal to sebelah over hypotenuse, right? Okay, so it is 4/5. Okay, and then for sin theta, it will be tentang cosine. Is it? Okay, so we just take, I think we just take sin cos theta. Okay, sin theta is tentang over hypo. Yes, correct. So it is 3/5. Okay, so we want to know the, okay, so the summation of Fy equal to 0. Okay, so we have negative 60 plus Cy and then minus 50 cos theta, right? Equal to 0. Okay, so negative 60 plus Cy, 50. So cos theta, we just take this one, okay? 4 over 5. 4 over 5 equal to 0. Okay, and then we get Cy equal to 100. Okay. Okay, now we are going to separate the members. Okay. So we start off with members that have less unknown force. Okay. Okay, so we start with member ED. Okay, so for member ED, we have, okay, so this is member ED. Okay, and we have E here, okay, E and D. Okay, here we have 50 lb. Okay, and then we have here, okay, so we assume here it will be in this way. Okay, okay, so we start with summation sigma and moment at D, okay, equal to 0. Since we want to know force at E, okay. Okay, and then so we have, okay, so here to here is 12, right? Okay, this way. So this is left hand, okay, so negative. And then from here towards here, 12 also. So this is left hand also, so it will be negative. Okay, so we just write negative 50 12 minus E 12 equal to 0. So we have E equal to negative 50. So E is 50, but in different direction, which is in this way. Okay. So and then we do summation Fy. Okay, vertical, which is this way. Okay, this way is positive. Okay, so equal to 0. And then we have, okay, since it is wrong, so we have to correct this one. So it is like this. Okay, and the value is 50. Okay, so here we have, okay, and then supposed to be like this. Okay, so we have D minus 50 minus 50. Okay, and then go to 0. So D is equal to 100. Okay. Okay, so that is for D. Okay, now we have member. Next we do member EF. Okay. Member EF. Okay, I think I need to open the lamp, switch on the lamp. Okay, so member EF we have in this way, okay? Okay, so this is E, this is F, okay? So since at E we know negative 50, right? Okay, we know that it is negative 50 at E. Okay, so we just put here, but in different opposite direction. Okay, so it will be like this. Okay, opposite direction 50. Okay, so the only force will be here, up here, which is equal to 50 also, but in different direction. Okay, so now we look at member AB. Member AB. Okay, so member AB have straight line. Okay, and then we have B, we have F in the middle. Okay, and then at the bottom we have A. Okay, okay. So again, we just label the force that we know. Okay, this one we know it is 60. Okay, this one we don't know, label as AX. Okay, so for B, it will have BS and also BY. Okay, and then at F we have like this one. Okay, force yang sengit. Okay, okay, and then okay, so first we don't know AX, BY, and BX. Okay, so we just have to determine this. Okay, we can do summation of moment. Okay, summation of moment at A. Okay, equal to 0. Okay, so because you want you can also put or is summation of moment at B. Okay, then we can determine the AX. Okay, now we want to determine the BX. Okay, so the moment is at A. Okay, so okay, and then this one we have to do for this one. Okay, for F. Okay, so F it will have force in this way, right? Okay, and then in this way, but since it is same direction here, so it is not counted. Okay, so we have to determine the angle first. Okay, okay, so before this we know this is 4, this is 3, this is 5, and then we have, let's say, theta here. Okay, theta here. So let's say you want to determine the cos theta. So cos theta is sebelah over hipo. So sebelah is 3 over 5. Okay. So let's see. Okay, now we want to determine the equation of summation moment at A. Okay, and then we have force BX, right? Okay. Okay, so let's say the forces is okay here. Okay, so for Bx, it will be going downward, which is 40. Okay, so this is left hand, so it is negative. And then we have component of x, forces of x here. Okay, and then downward 20. Okay, so this one is left and right hand, so it is positive. Okay, okay, so that's it. So now we write the equation. So we have Bx negative Bx, okay, 40, and then we have positive. Okay, so the force, the value force here is 50, right? Forget to write down. Okay, so 50 cos theta, right? Cos theta, and then multiply with 20 equal to 0. Okay, simplify. Cos theta equal to 3/5. 20 equal to 0. So we get x equal to 15 lb. Okay. And now we know the Bx, which is 15. Okay, 15. Sorry. So we just draw again. B here, A, F in the middle. Here we have Bx is 15. Okay, and then we have By. This one we have 50, 3/5. And then outward we have 50, 4/5. Okay. And then this one we have 60. This one we don't know. Ax we don't know. So we do summation. Forces horizontal x-axis equal to 0. Okay, so we have 15, and then we have negative 50, 3/5, and then plus Ax equal to 0. So Ax here we get equal to 15. Okay, now we do summation. Forces at y-axis, okay, equal to 0. Okay, so we have negative By, and then we have positive 50, 4/5. Okay, and then we have minus 60 equal to 0. So here By equal to negative 20, which means the force of By is 20, but the direction will be upward. Okay, so this one will be upward. Okay, now we do member BC. Okay, lastly is member BC. Okay, so okay, now for member BC, okay, it is sengit, condong. Okay, and then we have B, D, and then we have C. Okay, so for B, we have to look at this. Okay, we have to make sure it is in opposite direction. Okay, So which is this one will be downward, okay, downward, and then the value is 20, okay, and then for the horizontal, maybe to the left, the value is 15, okay. Okay, so and then we have external force, which is here, equal to 30, okay. Okay, and then for D, we have downward, okay, we have downward, okay. We have downward 100, right? Okay, 100. Again, we have to do the, this is 4, this is 3, and then this is 5. Okay, this is the data. So for this one, but okay, this is not necessary actually, okay, but it's okay. And then we have Cx, we don't know yet, okay, Cx, and then we have Cy, we equal to 100. Okay, now we are going to determine summation of moment at B, okay, since we want to know the value of Cx. Okay, so summation moment at B equal to 0. Okay, so we have to identify the force involved and the distance. Okay, we have Cx, okay. Okay, D is not considered because it is in line with B. Okay, so for Cx, the distance is 40. Okay, and then, so this is left hand, so it is negative. Okay, and then we have this one, 30. Okay, and then this is right hand side, so it is positive. Okay, so we just write down the equation. So negative Cx for T plus 100, 30 equal to 0. Okay, so Cx we get equal to 75 lb. So now we have all the forces for each member. Okay, so that's it. Okay, so thank you for today. Assalamualaikum. Okay, I forgot which one. Stop share. Okay, stop share.